Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss enthalpy of solution. Last class I have discussed enthalpy of bond. Enthalpy of bond. Now I am going to discuss enthalpy of solution. Then its symbol is delta SOL. SOL means solution. Delta SOL H. Okay, delta H. Near the delta you write SOL, sol. Okay, enthalpy of solution. Enthalpy of solution is a solution of a substance is the enthalpy change when one mole of it dissolves in a specified amount of solvent. Okay, again I am telling you, enthalpy of a solution of a substance is the enthalpy change when one mole of it dissolves in a specified amount of solvent. Okay, as for example, water is a solvent, universal solvent. The enthalpy of solution at infinite dilution. The enthalpy of solution at infinite dilution is the enthalpy change observed on dissolving the substances in an infinite amount of solvent when the interaction between the ions or solute molecules are negligible. Okay, again you listen carefully. The enthalpy of solution at infinite dilution is the enthalpy change observed on dissolving the substance in an infinite amount of solvent when the interaction between the ions or solute molecules are negligible. Interactions are negligible. Okay. When an ionic compound as for example NaCl, sodium chloride, when an ionic compound dissolves in a solvent, the ions leave their ordered position. Actually NaCl, it is arranged in a crystal, NaCl, NaCl, NaCl it is arranged in a you can say in a order. It is arranged in a well-defined order. Then when an ionic compound dissolves in a solvent, the ions leave their ordered position on the crystal lattice. These are now more free in solution. When they will leave their position, then they are more free in solution. But solvation of these ions, solvation means hydration, with each ion H2O will be attached. With each ion, or you can tell that surrounding the ion H2O molecules will be there. They will be very close to the ion, everywhere surrounding in a spherical way. That is called hydration. Okay. Then these ions I am talking about, these are now more free, means ions are more free in solution. But solvation of these ions, that is called hydration in case of solvent. Okay, hydration in case of solvent is water. Generally water is a solvent. Then solvation of these ions also occur at the same time. Means they are free to move here and there, but water molecules, where they will move? Only they will move in water, means solvent. Then surrounding the ions, hydration will be there, means water molecules will be there. Okay, and in that they are moving. Okay, that you can see that I will send one diagram. You can see in that also that from A, suppose AB is the NaCl. AB is the substance. A, capital A, small a, capital B, AB. You consider as NaCl. Then if you put in water, then what will happen? Solid, NaCl is solid. NaCl is solid, Na plus Cl minus. Then when you will dissolve in water, then or if you will dissolve also, you can tell, but you have to bring it in a vapor form. You have to bring it in the vapor form, means you have to heat it. If you will heat it, then this NaCl that will convert to Na plus Cl minus, gaseous state. Means from solid state you have taken it to the gaseous state. Then after that, these ions in gaseous state, after that it will go to the, suppose now you have put in the solution, or you can tell salt. First you have put in the water, salt you have taken, dissolved in the water, then in water it will be in the form of, you can say A plus and B minus, A plus B minus, and it will be solvated, means hydrated. Then you can write as A plus aqueous, AQ, a small AQ in bracket you can write near the A, plus B ion, B minus, that also it is in water only. Then AQ means aqueous, just write near the B. Then AB solid, if you dissolve in water, then it will dissociate in water in the form of ion. Then heat change during this process, that is called delta, means heat of solution. This is heat change in this process, means from the solid you have dissolved in the water, then it dissolved and broken into the ions. Then in this process heat change will be there. That heat change is called the heat of solution. Okay, now I am telling this other steps. Means now if you can say AB you have heated, then after heating also it will convert into the gaseous state in the form of ion. And this ion again, if it is dissolved in water, then what will happen? Because these ions now you have dissolved in water, then they will be associated with water. Everywhere water molecules will be there. That is called hydration. And then it will come to the original form. Original form means A plus aqueous and B plus aqueous. Means everywhere water molecules will be there. Then this happens what? Directly AB you have added to the AB solid added to the water, then you can bring it in the indirect way also. That first you heat it, then this AB you have heated to bring it in the vapor form, then some heat is required. Then when AB convert to gaseous form means A plus gas means gaseous state plus B gaseous state. Then in that process heat is required. That is called actually lattice enthalpy. Lattice enthalpy. I will come in details. Okay, after this. Then that is called lattice enthalpy. And after that it will come to the gaseous state after the heating. And after that, if we will put water, then it will dissolve in that. That will be called hydrated. Then in this process also heat is required. Means from the gaseous state, A plus and B minus is there, and you have dissolved in water. Then After dissolving in water, it will be associated with water molecules. That is called hydration. Then for hydration also it requires energy. Enthalpy change will be there in that process also. Okay. Then that is called actually enthalpy of hydration. That is called enthalpy of hydration, means two process. After the two process you are getting in water these things A plus B minus. A plus B minus means aqueous A plus aqueous B minus you are getting after the two process. We are telling directly just dissolve in directly water. But this can be done by this process. Two steps are involved in this. Then first process is, you can say, lattice energy or lattice enthalpy, and second step involved is there heat of hydration or enthalpy of hydration. Then you are getting heat of solution. Means heat of solution is equal to heat of lattice lattice enthalpy or heat of lattice, correct, plus heat of hydration. Heat of lattice or enthalpy of lattice you can tell, plus heat of hydration or enthalpy of hydration. Means this heat of solution or enthalpy of solution is equal to, it is the sum of lattice energy plus hydration energy in a simple way. You can write that delta sol means heat of solution is equal to heat of lattice plus heat of hydration. Okay. For most of the ionic compounds, del means heat of solution for the most of the ionic compound is positive. Why positive? Because heat is required to dissolve. That's why for most of the ionic compounds, heat of solution is positive, and the dissociation process is endothermic. Obviously, when heat you are supplying, then process is endothermic. Okay. Therefore, the solubility of most salts in water increases with rise of temperature. This is the reasoning why solubility increases with increase of temperature. If you increase the temperature, solubility will increase because molecules will dissociate into ions. It will dissolve in water. If the lattice enthalpy is very high, the dissociation of the compound may not take place at all, because that energy is very high. Then obviously that it will go to the gaseous state. At that time, dissociation energy will be, you can say, directly it will go without dissociation. Means it will dissociate, but that energy will be very less. Okay. The dissociation of the compound may not take place at all. Why do many fluorides, is again question is asked, why do many fluorides tend to be less soluble than the corresponding chlorides? Then you know that fluorine is, we can say, most electronegative element, and it will be attached with the cation strongly. Okay, that's why attractive force will be more, then it will not dissociate soon. But chloride can dissociate because it is not like fluorine. Fluorine, it is not like fluorine. Chlorine is a less electronegative element. hence it can dissociate, but fluoride, it will also dissociate, but it will require very high energy. Okay. Estimate of magnitude of enthalpy change may be made by using, you can say, when this is there, data is there, bond energies. Okay, already I have sent in the last class video, I have sent one chart that is for bond energy. Then estimation, during the estimation that chart is required. Estimate of the magnitude of enthalpy change, okay, may be made by using that chart tables of bond energies. Okay, that is also called enthalpy. And lattice energy also. Lattice energy means also, energy means always enthalpy. Now I am going to discuss lattice energy. This is very, very important. Okay, lattice energy, and under that only it will come a very, very important term, that is the Bond-Haber cycle. Bond-Haber cycle, B-O-R-N, Born, and Haber, H-A-B-E-R, Haber cycle, Born-Haber cycle, in the name of scientist. Okay, that will come under the lattice enthalpy. What is the lattice enthalpy? Then you can understand like that. Lattice enthalpy, I told you that ions will be arranged in a crystal. In a crystal, ions will be arranged in a proper way. Okay, when you are studying lattice, that is related to the crystal only. In crystal, they are ions will be, or atoms will be arranged in a proper way. Correct? Then lattice energy is related to that ordered arrangement. Okay. Then now just you try to understand the lattice enthalpy or lattice energy of an ionic compound. Okay, lattice energy generally will be for ionic compound, ionic. Okay, the lattice energy of ionic compound is the enthalpy change which occurs when 1 mole of an ionic compound dissociates into its ions in gaseous state. What I have discussed just before, same way here in means conversion of solid ions, means ionic compound, when it is converted to the gaseous state, then enthalpy, heat is required. Then that heat actually is called lattice enthalpy. Already I have discussed. The lattice enthalpy of an ionic compound is the enthalpy change which occurs when 1 mole of an ionic, 1 mole you have to consider, when 1 mole of an ionic compound dissociates into ions in gaseous state. Okay, this is the definition of lattice enthalpy. Example already I given you. Again I am telling you, NaCl solid is there and it will convert to Na plus gaseous state plus Cl gaseous, Cl minus gaseous state, and that time it requires, you have to supply heat. How much? Then 788 kilojoule per mole. Okay, this is the that is the heat of lattice or enthalpy. Okay, lattice enthalpy is 788 kilojoule per mole. 788, keep in mind for NaCl, because NaCl is common, then question is asked. Then when NaCl solid will be converted to gaseous form, means Na plus gaseous plus chloride and gaseous, that time heat required is called lattice enthalpy, and its value is plus 78 kilojoule per mole. That is the delta H value. Since it is impossible to determine lattice enthalpy directly by experiment, we use an indirect method. Okay, we use an indirect method where we construct an enthalpy diagram called a Born-Haber cycle. By the use of Born-Haber cycle, we can calculate the lattice energy. Okay, then what is the indirect method? Born-Haber cycle, that is the indirect method to measure the lattice energy. This also don't forget. What is the Born-Haber cycle? I have told you that it is the indirect method to measure the lattice energy. Okay, lattice energy of NaCl or salt, any other salt also. Then here we will discuss NaCl. Okay, Born-Haber cycle in case of NaCl. Here actually in this Born-Haber cycle, this is easy to understand. Easy to understand. It is in a cyclic form. Then here you know that first I will brief you, then I will come this in details. Here 5 steps you have to follow. 5 steps you have to follow. What are that 5 steps? Then I told you you have to bring can say ion from solid to vaporous gaseous state. Then it will come in 5 steps. It will come in 5 steps. NaCl was solid. Now you want to bring NaCl in gaseous state. Then total 5 steps are involved. Then I am telling step by step. First, sodium. Sodium is a solid. Sodium NaS you can write in bracket. Then sodium, first it will convert to sodium gas, means atom. Atom, Na, no charge, only Na, atom. Okay, gaseous state. Gaseous state, only Na is there. Then this is called sublimation of sodium. This is the first step. Now second step, this sodium atom, now it will convert to ion, sodium ion, Na plus in gaseous state, plus it will release 1 electron. It will release 1 electron. This is called ionization of sodium atom. This is the second step, means sodium converted to sodium ion. Now after that this sodium work is over. Sodium be converted into the sodium ion in gaseous state. Now think for the chlorine, chloride ion, how will it come? Then Cl2. Cl2 means half Cl, you can write as a half Cl2. Half Cl2 means Cl. Then half Cl2, that is the gas, that will convert into the chloride atom in gaseous state, not the ion, chloride atom, no, or chlorine atom, you can tell, chlorine atom in gaseous state. This is called, because gaseous half Cl2, it was in the gaseous form, now converted to the, you can say, atom form, chlorine atom. Then this is called dissociation of chloride, chlorine, dissociation of chlorine. Correct? This is the third step. Okay, and fourth step, just like sodium, here also same thing will happen. Chlorine atom will now accept 1 electron given by the sodium. That time you have seen ionization was there, then it released 1 electron. That electron will be taken by the chloride atom in gaseous state. Then it will convert to chloride ion. Now see, you have seen now solid sodium converted into the gaseous sodium, and this chlorine gas Cl2, chlorine gas half Cl2, that converted into the chloride anion in gaseous state. Then now both sodium ion and chloride ion are ready in gaseous state. Now what will happen last step? Then now both cation and anion will come together. Then they will form Na plus Cl minus solid. It will form NaCl, Na plus Cl minus solid it will form. Then now in these 5 steps, in all 5 steps, heat is associated. Heat change is there. Enthalpy change is there. Heat change means enthalpy change. Then here, if you will add all, then it will become like if you will apply the Hess law of constant heat summation, then it will become, actually you add all, then you will get the total heat involved in this process. Okay. Now I am going little details of this. Just I have briefed you so that easily you can understand. And this also, it will take a cycle form. I will try to send this Born-Haber cycle diagram. I will try to send it in video. Then now just these 5 steps, only little things I have to add. Then here, when Na will convert to Na gaseous atom, then gaseous atom, not ion, gaseous atom, then that is just called sublimation of sodium metal. Then sublimation we are telling in shortcut SUB, with the delta SUB you write. SUB means heat of sublimation, and in this process 108.4 kilojoule per mole heat will you have to give, you have to supply. Means delta H is positive, you have to supply this heat. This is endothermic reaction. Now second step, when sodium will convert to the sodium ion and means ionization, it will take place. Then that time this is called ionization of sodium atom. And heat, this time also heat is required. Then this is called ionization enthalpy. And delta H value. Delta I means ionization. A small I you can write. Delta I means ionization. Then heat of ionization, here it is 496.0 kilojoule per mole. Then two step I told you value. Now come for the chlorine. Then dissociation of chlorine to chlorine gas to chlorine atom, gaseous state. Then this is called atomization or also it is called dissociation of chlorine. Okay. Then in this process also heat is required. That is 121 kilojoule per mole. 121 kilojoule per mole. Okay. Then here this is written bond bond. Okay. Bond dissociation energy, generally with delta you can write bond bond. Then here bond energy, bond dissociation. Why you are using the word bond dissociation? Because it is a Cl2, half Cl2 we are telling, but it is a gas. Cl are attached. That's why you are telling bond dissociation or atomization. Both are same. Then here bond dissociation energy is 121 kilojoule per mole. Now you got the chlorine atom. Now fourth step, now this chlorine atom will convert to chlorine ion, means chlorine anion, it will accept one electron. Then here affinity is there, that now just like you can understand that you want to purchase some things, you are ready to pay something for that which you like most. Which you like most, you are ready to pay something. Like here also, that chlorine atom, chlorine atoms are ready to, you can say, pay something to take the electron. That's why it is called electron gained. Electron gained by chloride atom, and also called, you can say, electron gain enthalpy. And for that, this process actually it will release heat. It will release heat. It is releasing heat for, they are paying means here releasing heat. In other cases you have seen it was absorbing, but now in this case this is also called affinity, electron affinity. I will tell you some differences are there between the electron affinity and this electron gain enthalpy. Some differences are there, but in broader sense both you can understand same. Okay, then its value is minus 348.6 kilojoule per mole. Delta H is equal to minus 348.6 kilojoule per mole, and then it converted to chloride ion, okay, anion. Then this 4 step I have told you. Then here these things, ionization enthalpy and electron gain enthalpy already I have discussed in the beginning only in the atomic structure chapter. Okay, you are knowing these terms have taken from thermodynamics. How this term has come, then how it has come only from this chapter. Thermodynamics means, chapter means here from this thermodynamics these two terms has come. Okay, earlier terms was ionization energy was there, that is the same ionization energy. Now actually enthalpy term has come, ionization enthalpy you are telling, and other term you are telling electron gain enthalpy. Okay, but before this it was called ionization energy and electron affinity. Old name of these two terms, ionization enthalpy and electron gain enthalpy, its old name was ionization energy and electron affinity. Till date people will call by this name also, because some similarity is there but some change is there. What are that change? That I am giving you some advanced knowledge that is you should understand. Generally people are not, students are not knowing, but now I am telling you what is the difference. Actually here in ionization, suppose metal was there, generally just in a general way you consider capital M metal, that is suppose it is in a gaseous state, then metal will convert to the metal ion M plus, and that time it will release electron. Then previously it was called ionization, correct? And that electron what it was released, if any other metal will take which is in gaseous state, then it will convert to the metal anion. Metal ion means anion. Then it is called, this is actually electron gain, that is called electron gain. Okay, then in the beginning affinity, it was called affinity, but now actually what happened, this process was actually considered at can say 0 degree temperature. This ionization and electron affinity term was considered, this process was taking place when temperature was 0 degree. means 273 plus 0, 273 Kelvin. Okay, that time it was called ionization energy or electron affinity. Okay, but now if you will consider the temperature, any other temperature, suppose this process is going on, then temperature you are considering, and when temperature you are considering, then heat capacity also you have to consider. Okay, heat capacity, already I told you to heat required to raise the temperature by 1 degree. When temperature you are considering, the heat capacity also you have to consider. Then if you will consider the heat capacity and temperature, then that time this delta H value means ionization energy and electron affinity. That time when heat capacity you are considering at a particular temperature, then delta H, that time this heat of reaction means delta H in bracket capital T you can write, because temperature you are considering, then that will be delta H at 0 degree, delta H at the time of 0 degree plus you can say integration sign 0 to T. What was the heat capacity? Heat capacity means you can say Cp into delta T. 0 to T integration you are doing. You don't know what is the temperature value. 0 to T. Then 0 to T you are doing integration for Cp value, delta Cp value for dt temperature. Means in a simple way you have to consider, when you will consider the temperature, then obviously you have to consider the this Cp heat capacity. Only then you can tell enthalpy. Enthalpy term came only when you are considering temperature, and temperature means obviously heat capacity, then term converted into enthalpy. Okay, now I think it is clear. The value of and again one more thing, important things I am telling you, the value of Cp, the value of you can say Cp for each species to the this reaction what I told you for ionization and for electron gain. For that, the value of Cp for each species in the what I told in that reaction, its value means reactants. I am talking about the reactants. Its value is 5 by 2 R. Its value is Cp value is 5 by 2 R. Okay, Cp value, and Cv value is 3 by 2 R. Cp is always Cp is greater than Cv. Already told you Cp minus Cv is equal to R. Then Cp value is always greater. Why greater? Also I told you, because here that heat is going to be used in two parts. First in expansion, and after that rising the temperature. Hence more heat is required at Cp, but at Cv, because volume is constant, hence whatever heat you will supply, it will go only in expansion. Hence Cp is greater than Cv. Then Cp value is 5 by 2 R and Cv value is 3 by 2 R. Okay. Then for Cp I told you plus 5 by 2 R for ionization. For ionization plus 5 by 2 because heat is required. Then its value will be more, plus 5 by 2 R for ionization, and for Cp value for electron gain, then it is minus, already told you minus, then it will be minus 5 by 2 R for electron gain. Okay, this I have told you, means for ionization plus 5 by 2 because heat is required, and during electron gain reverse, that's why it became minus 5 by 2 R. Therefore ionization enthalpy include two terms. E0 means you are talking about energy at 0 degree centigrade means 273 K, okay, plus 5 by 2 RT, and this heat of reaction for electron gain, then electron affinity value A, okay, minus 5 by 2 RT. Okay, electron affinity, that is denoted by A, capital A, then minus A, minus 5 by 2 RT for affinity. Okay, this I have told about what is the why people are telling enthalpy. Now I have told you. Then there is a difference between enthalpy and heat, but in a broad sense you can tell same, but it is different. I have told you. Then now fifth step, final step of Haber cycle, Born-Haber cycle, that now Na plus is ready, Cl minus is ready. Hence now they will combine and it will convert to solid, means NaCl solid. Then now here what will be the value of NaCl solid? Just to understand the sequence of steps, what I have told. The sequence step total 4 I told you, 5th I am going to tell. That is the what I am telling you going to tell, that is the 5th step. Na plus Cl minus, that is the NaCl solid. This is the 5th step. The sequence of steps, okay, what I have discussed is known as Born-Haber cycle. The importance of the cycle is that, what is the main importance? The importance of the cycle is that the sum of the enthalpy change around a cycle is 0, Z-E-R-O, 0. Okay, this is the importance of the cycle. The importance of the cycle, Born-Haber cycle, is that the sum of the enthalpy change around a cycle is 0. This question is asked. Okay, objective type question. Now, if applying the Hess law, if you apply the Hess law, means you will add in each step what was the energy associated. Then you will find delta H lattice, means lattice energy is equal to delta lattice is equal to what? Then lattice energy, lattice enthalpy is equal to, now add all values what I have told you, that here minus 411.2, okay, plus 108.4 plus 121 plus 496 minus 348.6, all step 5 steps I told you, 1 2 3 4 5 steps you have added. In the diagram you will find all things, okay, all 5 values is written. But I am telling you one thing you may ask, actually in diagram, in cycle, its value is given minus 411.2, but here we are writing plus 4112.2. What is this actually value? Then this is the heat of formation. Then heat of formation, heat is going out, correct? That's why it is minus, okay? But here, if you are going to, you can say during the formation this amount of heat went out, okay, then it was solid. After releasing this heat, it was solid. But now from the solid, you are bringing it to the gaseous state. Then this minus is converting to plus. Converting to negative sign, it is converting to positive sign. Hence, that negative 411.2, that is written in positive 411.2 plus 411.2. Okay, then that 5 steps, 5 values I have given. last value, that is this Na plus Cl minus NaCl forming. In that actually that 348 distinct 348 1 2 3 4 5 348.6 kilojoule 348.6 kilojoule that heat will come out. Okay, then here you add all, then you will get 788 kilojoule. That is the lattice energy for NaCl. Lattice energy means when you bring from solid state to the gaseous state, then all energy, total energy is required 788 kilojoule. And then stepwise I told you. Okay, again little more, you know that NaCl, it will gives Na sodium ion gaseous state plus chlorine ion gaseous state from solid NaCl. Okay, internal energy is smaller by 2RT. Okay, here internal energy of NaCl I am talking about, that will be internal energy is smaller by 2RT. Why? From where? 2 came. Then because NaCl molecule was only one, it converted to separate Na and Cl. Then now it became 2. 2 ion means 2 molecule. Delta ion became 2. Then here it will be, you can say internal energy is smaller by 2RT because delta n is equal to 2, and its value will come plus 783, little less. It was 788, now it is becoming 783 kilojoule per mole. Now we use the value of lattice enthalpy to calculate enthalpy of solution. Again here second importance, second application you can tell or benefit of this Born-Haber cycle. Now you can calculate enthalpy of solution. Okay, then how we will calculate? Then already in the today when I started, that time I have told you about the heat of solution. Heat of solution is the sum of lattice energy plus hydration energy. Then now you can calculate that we know that heat of solution is equal to heat of lattice energy plus heat of hydration. Then here heat of hydration you will be knowing, for 1 mole of NaCl solid, lattice enthalpy now you have calculated 788 kilojoule per mole. You have calculated now, just now only. And this hydration energy, how will come to know? Then from the actually chart will be there, literature will be there, and just like one book will be there. In that all hydration energy for all, you can say, molecules will be there. Okay, then from that chart you can see the hydration value. Okay, hydration value for sodium you can know by that. Then now both value you are knowing. Lattice energy you are knowing 788 plus this value means hydration energy value from the chart you can know. Then just you add both, minus 784 delta H for delta H, that is the distance. This you have calculated plus 78. Plus 78 is the lattice energy, plus 78 kilojoule per mole. And for hydration energy is minus 784, minus 784, minus means heat is liberated when water molecules will come around the ion for hydration purpose, then heat is released. It is a minus value. Heat of hydration. That time when water molecules will be associated with ion, for chloride ion or for sodium ion, for any, and that time heat is released. Its value I am telling you that hydration energy value is minus 78.4 kilojoule per mole. Both value you put, then you will get the this value of, you can say, solution. Then delta S, I told you delta S means heat of solution is equal to heat of lattice energy plus heat of hydration. Now both value you can put and add it. Then one is in other positive, other is negative, hence value difference is very less. That is the plus 4 kilojoule per mole. Numerical is as it is just like a numerical only. Okay. Then the dissolution of NaCl is accompanied by very little heat change. Okay, very little change. In the beginning I told you dissolution of NaCl means when it is dissolving, NaCl is accompanied by very less heat change. Okay, and already I am sending every time some numericals. Okay, you try to understand the numericals. That type of numericals will be asked in competitive examination, and try to understand. I am sending some already. In last 2 classes I am sending just to try to understand. Okay, whatever possible I will send the numericals also just to understand, try to understand. Okay, now I am stopping only here. Next class again I will meet you. Thank you.